Hey, welcome back. So today we are going to solve the question implement lower bound. We are given a sorted array and a number target. The task is to find the lower bound of the target in the given array. So what do we mean by lower bound? The lower bound of a number is defined as the smallest index in the sorted array where the element is greater than or equal to the given number. So what do we mean by that? Suppose we have this 2, 3, 7, 10, 11, 11, 25, yeah, and the target is 9. So what is the lower bound of 9? It's an element which is just greater than or equal to 9. So in the given array, what's a number which is just greater than or equal to 9? We can see it is 10, and 10 lies at index 0, 1, 2, 3. So we would be returning answer as 3. So the thing is like how we are going to approach this question. Since the array is already sorted, uh, we can perform a binary search and get the lower bound of the given target. So let's see how. Let's say we have a low pointer and a high pointer, and we check the mid element. So the mid element is 10. So let's check if the mid element is greater than equal to 9. Yeah, it is. So we would be storing answer as the index. So it's um, let's mark the indices first. Yeah, so the answer here is 3. Now we should also keep checking for the smallest lower bound or the smallest element which is just greater than the given target. So what we can do is we can reduce the higher search space. So we can do something like we'll reduce the higher search space by mate minus 1. So the elements this would be cancelled, this would be cancelled, also the mid element would be cancelled, and the high would move to mid minus 1 here. So high comes here, and again we try to get the mid, so mid appears here. Now let's check if the element at the mid index is the smallest lower bound. Since 3 is not equal to or not greater than equal to 9, false. So we would be uh, moving the lower search space towards the higher search range. So low would be moving to 2 would be cancelled, 3 would be cancelled, and low and high would now coincide. So again we find mid. So mid appears here, and let's check if the mid element in element at mid index is greater than equal to 9. 7 is also not greater than equal to 9, so this is also false. And since we are left with no more elements to check for, we can safely return answer as 3 in our case. By the way, if we were given duplicates, let's say we had 2, 3, 7, and two tens, 11 and 25, and the target element was 9. So if we would have got 10 at this index, which appears to be at index 4, so we would be storing answer as 4, but we should find the index of the first 10. So what do I mean is if there are multiple lower bounds for the given target, so we should return the lowest possible index of the lower bound found. So that's what I wanted to say. So answer would be basically 3, not 4, which is at 10 at index 3, which appears to which appears to be the lower bound at the minimum possible index. So this is a valid approach, and we can pretty well now code it up to see if this approach works. So let's move to our code editor. Let's assign low and high pointers, which is 0 len of error, the array -1. Also, let's store answer. Initially, let's assign it with -1. Now let's run a loop where a low would run until it's lesser than or equal to the high pointer. Get the mid, which is low plus high by 2. Also keep track of the element at the mid index. So let's call it current element and error of mid. Now let's see if the current element was just greater than target. Let's store the index of it and reduce the higher search space to find the lowest possible lower bound. And if there are multiple duplicates, then that should also work for this. We would be finding the lowest possible index. So reduce the higher search space by moving high towards the lower search space. Else continue by moving the lower search space towards the higher search space, and we can safely then return the answer. So let's return the answer and check. And as you can see, our first test case compiled successfully, and it was correct. So let's submit our code and check for the remaining test cases. Okay, so it's failing for the test case where the target element is 100, which is actually not present. Okay, so if an element is not present, okay, so return answer only when answer is not equal to -1. Else we can return the length of the array. Why I'm telling length of the array? Since 100 was not present, and there is a an element 25 at the highest index in the array. So we can return. There would have been an element present at index just beyond 25. So it would be safer to return index of that. So it's nothing, it's just the length of the array. So we can return like else we can return the length of the array. So let's check if this works. Yeah, it worked, and it passed all test cases, and it was pretty efficient and followed the logarithmic time complexity. So yeah, this was it, and we would be meeting in our next video. So I hope to see you soon.